This one is number 45, and this is in chapter 9. Hopefully you got a chance to try it first. This is how I'm going to solve it. So what we have here is Paul sitting on a mat being pulled by his sister. But his sister is pulling this with a constant force of 30 newtons, and it's at an angle 30 degrees above the horizontal. Right, and he's sliding across the floor. We have that the coefficient of kinetic friction is 0.20. Okay, so we want to use work and energy to find Paul's speed after being pulled 3 meters. Okay, so I'm going to do a free body diagram on Paul right here, or Paul's mat I should say. There's tension going this way, there's gravity this way, there's a normal force here, and there's a friction force here. And we need to know which way he's moving. He's moving this direction with 3 meters. Notice I don't ever connect that into the free body diagram because that is not a force. That is the displacement vector. But we need to know what direction that is. Okay? Now, let's look at this. If he's moving this way, does the normal force do any work? And the answer is no, because the normal force is perpendicular to the way it moves. And if it's perpendicular, it does absolutely no work at all. What about gravity? Gravity in this case is perpendicular to the displacement vector as well, so it does no work. So the only forces that are doing work are the tension force and the friction force. So let's do the work done by the tension force. Work done by the tension force is just going to be the force times the distance times the cosine of the angle. But in this case we know the force is 30 newtons. We know the distance is 3 meters. And we know the angle is 30 degrees. So the work done by tension is equal to 30 times 3 times the cosine of 30, or 77.9 joules. That's how much work Susan is inputting. Now we got to do the friction force. Now the work done by friction, we haven't talked about this before. I'm going to add a little thing at the end here, but work done by friction is done the same way. FD cosine of the angle in here. But the friction force, we know, is mu sub k times the normal force times the distance times the cosine of the angle. Okay? But in this case, the normal force is just equal to mg, so this becomes mu sub k times mg times the distance times the cosine of the angle, but the angle is going to be 180 degrees. Will the angle ever be anything but 180 degrees? No, it can't, because remember, friction always opposes motion. If a friction opposes motion, whichever way the displacement vector is, friction's always the opposite way, so that's always going to be 180 degrees. It's always going to be negative work. Essentially, friction will always slow things down. Now we know what those are. This is 0.2 times 10 times 9.8 times 3 times -1. And we get the work done by friction is equal to negative 49.8 joules. Lots of times we will call this energy instead of work, because what really happens is friction is heating up the floor. It's like when you rub sticks together to create a fire. And so we can call this the thermal energy. The thermal energy is going to be equal to 49.8 joules. Notice that's different. The energy, I'm going to put it as positive. But the work done by the friction is negative. But the amount of energy, or essentially the thermal energy, the heat, is a positive thing, because you're heating up the mat and the floor with the same amount of work that is being done by the friction force. All right, we want to find, though, Paul's speed after being pulled 3 meters. To do that, we're going to use our same thing where the net work is equal to the change in kinetic energy. Okay. All right, and we're going to assume that it started from rest. I think it says that it starts from rest. So the kinetic energy final minus the kinetic energy initial. Well, the initial is 0, and the net work then must be equal to kinetic energy final. Or we just add the works together, so we have 77.9 minus 49.8 is equal to 1/2 the mass times the velocity squared. Okay. Or we're going to get that this is 28.11 joules. 28.1 joules is equal to 1/2 of 10 times v squared, or 2 times 28.1 over 10. Take the square root of that and we get the velocity. We get that the velocity is equal to 2.37 meters per second, or 2.4 meters per second for 2 sig figs. Yes, you could do this the way we did it before in chapters 5 through 8. You could have solved for the net force here, set it equal to ma, and then used your constant acceleration over the 3 meters to figure out how far, what the velocity is. You would have got exactly the same answer. But it's nice to do a work, and on the test, when I ask these, I'll ask you to do it by work. You have to show it in the work method, so make sure you do it this way. All right, that was number 45, chapter 9.